Shall we get started?
Sure, yeah. Aiko, would you be able to start things off? I think Aiko's having some mic trouble, so I'll just get everything started. So hi, everyone. Thank you so much for coming to this event. So this is our first SWE Club event. So we'd like to thank the president for Society of Women Engineers San Diego, Ms. Kelly Kloster-Hahn, who is with us. She was kind enough to accept our invitation to come and speak. We'd also like to thank Dr. Nguyen, who is our SWE advisor. So Ms. Han has prepared something for us, and at the end, we'll be able to open everything up to questions. So if you'd be able to share the presentation.
Yeah, welcome everybody. Thank you for taking the time this evening to listen to my story. And like Reed said, I'm happy to answer questions at the end, or if you have things in particular during the presentation, feel free to put them in the chat window and I'll aim to capture those as well. Wanted to first thank Reed, who was so brave in reaching out to me and engaging in this conversation and sharing with this newly formed SWE Club all about my story, how I've been able to connect with SWE and my journey as an engineer. So for those of you that don't know me, like Reed indicated, I am the Society of Women Engineers president here for the San Diego professional chapter. And we as a SWE organization are a global organization, for those of you that aren't aware, with over 40,000 members worldwide. I myself actually happen to participate for the first time in college, and I will get into that here in a moment. I'm going to start by sharing my screen where you will get to see my journey, and we will dive into that. Okay, I should be able to see my screen now. So my journey actually began well before Georgia Tech. I'm originally from the East Coast. I grew up in the Washington, D.C. area. And I grew up going to actually a German school. I'm bilingual. I speak German and some French and English as well, of course. And at the German school, they push the math and sciences very much so. And when I finally switched to an American school, everything still in the US, I transitioned in the 4th grade, and I actually was at an 8th grade level for math. And I may have been at a 1st or 2nd grade level for English. So you can see how that balances out. But math has been kind of one of those universal languages for me, and something that I found very easy for myself because of the patterns that exist there, and a huge passion of mine through my experience in school and college has been on the math side. I transitioned to an American school, like I said, and the sciences were an area of interest, but most specifically physics. So in high school, I was able to take AP physics, and my physics teacher noted a big spark in me on the physics side and encouraged me to start a club called JETS, the Junior Engineering Technical Society. We didn't have SWENext clubs at that time, so this was probably the next best thing. And through the Junior Engineering Technical Society, I was able to lead a number of other aspiring engineers or technical minded individuals in some activities, as well as an end of year exam to compete against other students in schools around the world. Being in the Washington, D.C. area, it also afforded me opportunities to participate and engage in activities and events local to that community. We've got a lot of the military presence, so a lot of the tools and resources that we use today, like the internet, got common for the common folk through the support financially from the military. So it's neat to see some of those ideas before they come out to the consumer in that environment. This is very neat. So in high school, like I said, I had that physics teacher, and she really encouraged me to pursue engineering. And when looking for college, I happened to look at a number of different engineering disciplines. I actually also simultaneously did take an aptitude test. And through that aptitude test, it encouraged me to pursue either architecture or engineering. I actually happen to have a number of engineers on my mom's side of the family. My grandfather is an aerospace engineer. My uncle is a mechanical engineer, and we have family in the aeronautical engineering space as well. So a lot of engineers on my mom's side of the family. And it seemed to me that even though I have a lot of spatial reasoning, that the engineering side made a little bit more sense. And in studying the various disciplines, picked mechanical engineering. And in picking mechanical engineering, I then studied the number of universities around the US to figure out where might be a good fit for me. Like I alluded to, I came from the Washington, D.C. area, Virginia, Northern Virginia area. And so I'm used to living in a big city. And when looking through the universities, Georgia Tech happened to be number 2 at the time for mechanical engineering. And I visited the campus and fell immediately in love with the atmosphere, the students, the international environment and opportunities that Georgia Tech afforded. And it just felt like an immediate fit. So I was really excited. I, at the time, applied and was accepted in the spring, I guess around this time, and was really excited to begin my journey at Georgia Tech. At Georgia Tech, again, I studied mechanical engineering and really focused early on and appreciated the product development side of the world of engineering, not so much acoustics or fluid dynamics, but the product development side. And in my capstone, I worked with industrial designers, specifically by choice, because I like interdisciplinary activities, and worked for Delta. Delta is headquartered in Atlanta, and we have a big partnership with them and Georgia Tech with doing activities for them. And so I actually got to solve a problem that they had in the field. So when those flight attendants are pushing those carts up and down the aisle, they're actually pushing quite a heavy load. And during turbulence, sometimes those carts can get a little rickety. And the carts were actually hurting some of the flight attendants, because the flight attendants would try and grab them from tipping over and hurt their wrists, or they would fall over and hurt an ankle. And so they were getting a lot of injuries on these because of the carts. And so my task was to come up with an addition to the cart. We couldn't design a brand new cart, but some sort of add-on to the cart that would help solve this concern and issue and reduce the amount of injured flight attendants due to carts tipping and falling over. So that was a very neat project for me. This is the product on the right that we ended up coming up with after many ideas and iterations. But basically what happens is the caster wheels, they rotate when the cart's about to tip, and they rotate to the worst case possible situation with a main point all the way on the inside of the cart. And so once it starts tipping, it just tips even faster. And so by adding a component here that you're seeing on the screen, a metal foot is moving the point of contact from underneath the cart to outside of the cart. And so this device actually didn't prevent from falling and tipping, but it stopped it from falling once tipped, which was a really neat device to be able to add on to the carts. In addition to this design, we also evaluated as a team how the carts are packed. And so when the carts get loaded, often in the past, what was happening is the water was loaded in the carts at the bottom. And then immediately when the flight attendants are ready to serve, a lot of people want water, and they would move the water from the bottom of the cart, the best place, gravitational location for it, all the way to the top of the cart. And again, creating a situation of possible tipping for this cart. And so what we did is we came up with these side holders for those water bottles to help with lowering the point of location for those water bottles, and helping retain the access necessary for the flight attendants. We also evaluated the cart loading of how, where the sodas are, where the other snacks are, and helping them prioritize that, and created an app so that if they changed up the cart to the way that they prefer it, they'd be able to see visually if that's a potential risk for an increase in tipping and falling. So creating a number of tools for them to use and eventually implement. Some of these were implemented and can be seen on flights today, which is exciting to see your work out in the field, and really reinforced for me the importance of the work that we do as engineers, not just to design awesome and pretty products that function, but also the impact that they can have on the use and the safety for those patients. So it was a great experience for me in my senior design. Some experiences that I had before were through internships. So coming back to this first screen, so at Georgia Tech, that was my senior design capstone. But before even getting to that senior design, I did a number of internships. I interned in the Washington, D.C. area in a very traditional mechanical engineering discipline of HVAC, heating, ventilation, and air conditioning. That was not a topic for me. Working for the government indirectly was a much slower pace than is what works with my personal lifestyle. I then worked at Amway, which is the image here, the second image. I worked in a manufacturing plant. Amway is located in Michigan, so I spent the summer up in Michigan. And in that location there, which is about a mile-long site, they have 7 manufacturing plants. So it was my second real exposure to manufacturing plants, which was really cool. The summer before, I had spent a summer in Germany visiting about 17 different manufacturing facilities in Germany, everything from porcelain factory plant to Henkel, which is the equivalent of Johnson & Johnson, where they're blow molding bottles and things of that nature. So all sorts of different manufacturing. And I decided to do a manufacturing internship, did that at Amway, and specifically worked in the pressure packaging plant, where I was in charge of optimizing their line that had a lot of downtime. So I did activities and events, Kanban events around a specific product there. I optimized a line and was able to decrease their downtime and increase their throughput, specifically on their highest downtime product, which was this Tresemme hairspray. So Tresemme manufactures some of their products there in Michigan at Amway's manufacturing plant. And so after my time at Georgia Tech and after that senior design project, I ended up studying over at the University of Stuttgart. I did my master's in product development. Like I mentioned before, mechanical engineering is a very broad topic, anywhere from robotics to fluid dynamics to acoustics. I mean, there's all sorts of, it's a huge range of opportunities, and product development was the area that I wanted to focus on. And at the time, Georgia Tech didn't have discipline focus areas that it does today, which is really neat to see. And so I decided to get my master's to really dive deeply into product development, and did so at the University of Stuttgart. I completed my master's in German over there in Germany, and was really able to experience another culture and how they teach, again, kind of like coming full circle, starting my educational career at a German school and then ending it here at the University of Stuttgart as well. I took those learnings and my desire to work at an innovative company to my first full-time job at a design consulting firm, Big Bang. So some of you may have heard of an organization called IDEO. And this is basically a smaller version of that, located specifically in Atlanta, doing all sorts of projects. It was a really neat opportunity for me to do a variety of things, anything from designing a brand new coffee grinder, where I was evaluating the differences between a coffee ground through a burr grinder, which is what some people grind their coffee in using blades, or the coffee grinders when you grind them at a big factory operation like a Starbucks where they would buy their coffee, is actually using grinders that are not chopping, but are grinding through the coffee in a different than a blade manner. And so, you know, things of that nature, where I was sieving through coffee and evaluating the different sizes of coffee grounds and seeing which operating mode actually creates the optimal ground coffee, and then designing an actual product for your kitchen to fit on your kitchen countertop that would fit and not be this industrial sized product, but small scale and on the counter. So I did projects like that. Another project was investigating at-home shavers shower shavers. So interviewing men who shave in the shower and observing them with a bathing suit on through a GoPro from their living room as they shave in the shower, and then doing those informational interviews. So learning and developing personas to figure out who is our target audience, the different types of users of a product, and then ensuring that when we design and develop an ultimate product, that we're meeting the needs of all of those different customers. So really taking a product from that front end, designing and developing around it, and then ultimately releasing that product. The picture I have here on the screen, let me see right here, is one that I have a patent on. It's a sternal retractor. This device is used for open heart surgery. This is a project that I did at Big Bang. I worked with the top heart surgeon at Emory Hospital. And during open heart surgery, they will cut this sternum bone, which is this center bone that you can feel on your chest. They cut it open, they cut it in half, and then they place this sternal retractor on in between where they've just cut open, and they crank you open. And as you can imagine, when you're cranking your bones open, you're not a perfectly parallel person, because you've got different sized ribs coming up on your body. And the current medical device sternal retractors are opening very parallel to one another. And so this device that I have a patent on opens and flares with your sternum. So your sternum will open more at the bottom and stay tighter at the top. And so this device will mimic that shape. And the importance of doing so is to keep the pressure evenly on the sternum bone. And so before, when they were opening up the sternum, they were not in contact basically with one point on the sternum, but with this device, they were evenly contacting that bone. And by doing so, they're also able to minimize the amount of blood loss, because they're able to collect and retain some of that blood. And when you reduce the amount of blood loss, you're decreasing the amount of time a patient is having to stay in the hospital, and the amount of blood that we're having to give to the patient during the operation that we, as donors, provide to the hospital. So many advantages to this design, and a very neat project that I got to work on there at my time at Big Bang. This is a project that I like to talk about, because I got to work on a product where I had to think about tolerance stack-ups. It's something mechanical engineers work on a lot. The concept here, this is a device used to provide relief to your dental pain. And this product comes with a number of those blue applicators with the fuzzy tip. And the idea is that you would apply this to yourself, but you don't want to touch the end of the disposable product, and you need to be able to attach them and dispose of them ideally without touching. And so there's a collar that's on this device that you pull back. The front of the device will be open enough for you to insert the blue tip. Then you slide the collar forward and it will stay retained. And then when you move the collar back, it will fall out of the device and into your trash can. So I designed this entire device and was able to do so focusing on, again, those tolerance stack-ups. What does that mean? Well, sometimes when we're manufacturing, and every time we're manufacturing, things are not going to be the same across the board. Those blue applicators, they're going to be different sizes. They're not going to be perfectly round, and they're not going to be, even if they are somewhat perfectly round, they may have different sizes. And we know the upper bound and we know the lower bound. And same with our actual handheld device here, that also will have an opening and a closure that's going to change based on the tooling and the cavity that it comes out of. And so my job as the engineer is to make sure that the lower end of the applicator and the upper end of the handheld device, that in those worst case situations, they still function as I expect, and vice versa. The biggest applicator will still fit in the smallest handheld device. So those are tolerance mathematical applications that we have to put together to make sure that this product will function as it's intended. I also got to design the product using Creo and coming up with the multiple pieces, how it's going to come together, but then also from a manufacturing perspective, how is this going to be made? That blue piece is an overmold, so it's a soft material. And so we're having to think about where where the injection point's going to be so that the user's not going to have see where that injection point was made, and that it looks how the industrial designer intended it to look. So a lot goes into each of these products that we design as engineers, and this is what looks like a very simple project, but a lot of engineering application that gets into designing some of these products. With that, I ended up doing a lot of work. I think I did about 12 projects in 17 months for various customers: Hamilton Beach, General Electric, all sorts of customers, from individual inventors, like I talked about, to these large companies in medical device and consumer products. And I decided to transition my time to Newell Brands. And Newell is a company also located in Atlanta that I had actually interned with while I was at Georgia Tech. When I interned with them, I worked with them on strollers. I designed and developed an aspect of this foldable stroller. So I worked in their stroller department. But Newell, you know them as Sharpie. So Sharpie is one of their brands. Calphalon cookware is one of their brands. Yankee Candle, K2 Skis, Marmot Clothing, and Dymo, as well as then Graco. So Graco was one of the brands that I worked with and designed the stroller for. And I returned to Newell after my time at Big Bang to really dive back into hardcore heavy engineering, because my time at Big Bang had been transitioning based on the customers that we had. That's how that's how consulting works. You get the work that you do is dependent upon the customers that you have. And at the time, it was leaning a little bit more towards industrial engineering and more the front end of user needs. And I wanted to dive into some more engineering heavy focus work. So I went back to Newell Brands, and with Newell, I worked on all sorts of products. This is a product that I designed. It is used by Rubbermaid for the Rubbermaid commercial products. It's used by cleaning people. So when they're cleaning offices or hospitals or other spaces, they have these microfiber cloths, which we're all so much more familiar with now that we have been at home here with COVID. And what they do is they dump fluid into this container, which then saturates those cloths. And then they're able to use those throughout their cleaning process. And this particular project, what I was doing was I was reducing the amount of plastic. And in doing so, I needed to not only reduce the amount of plastic we were using, which helps save costs and money, value added, value engineered is what we call that. But also I needed to retain the rigidity and strength that this product needed to withstand in that environment. So things that I added in this design were the ribs that you can see on the corners to design that feature, but also featuring in snap fits. So that container lid was able to open up and close, but still have the rigidity again that it needed to have. So very neat project of evaluating a current design, taking it and optimizing it from a material usage perspective, something that we do as engineers as well. I designed this cake carrying device. Some things that were unique to this were the snap features on the edge of the cake carrier needed to be able to snap in place and hold whatever cake you might put on it, or maybe it's a pie in a glass pie shell, and I needed to make sure that it would hold all of that weight. Very important. I actually have this cake carrier up in my cupboard here, and I use it quite often, mostly for deviled eggs, I would say. Another feature was the handle, which is actually able to snap in place in that upward position as well as in a flat position. Those are some snap features that, again, using tolerance analysis and the design of it, able to come up with those kinds of solutions. And then from a FEA perspective, ensuring that this plate that's standing there is able to be molded in as thin of a plastic as possible, but still maintain the rigidity and structure of staying flat so that we're not having warpage happening. When designing all of these products, which you can see most of them are plastic, us as engineers were responsible for designing and defining where we're going to be how we're going to be molding this, what those where those parting lines are intended to be, and how the tool will be opening, where the injection point's going to be, how many injection points there's going to be. And so we do a lot of mold flow analysis when doing so. And we use tools that are directly in our software, our design software of SolidWorks or Creo, to figure out what that's going to look like. The software can show us how the mold is going to be filled, and we can confirm that our design intent is going to be correct. And we're always partnering with our marketing and industrial design teams to ensure that our ultimate engineering selection, while optimal, may not be their preference. And so we can work together to find the optimal solution for the total package of this product. And then lastly, at Newell, my main brand that I supported, coming back to it a second time, was Dymo. Dymo is the labeling product that they have. And I got to work with a global team, a team in Belgium and China and throughout the US, to design and develop 2 separate label printers with new features. So at the time, these labeling devices didn't have Bluetooth or Wi-Fi connectivity options. And so that was a new feature we were adding. And in doing so, I got to work a lot with electrical engineers in this project, in addition to my usual suspects of industrial engineers and marketing. So it's very neat to get to work on this project. I happen to have also, on this particular device, work with OEM. So I worked with people in China who were responsible for doing all of the CAD. And my responsibility was to provide them with the design and the inputs and the guidance as they put together the actual CAD work. And so that was a neat project for me to become a leader and grow as an individual, not just to be a contributor, but really be that liaison and point of contact between the teams in the 2 different locations, and in this case, actually 4 different locations. I also personally designed another labeling device and got to 3D print many in the shop and clean off all the 3D printed product and come up with the different designs around the marketing and industrial design recommendations in those kinds of situations. The big things that I am needing to think about is, how are those electrical components going to interface with the design that we've come up with? And how is this interface also going to be manufacturable? What are we going to actually be able to do? So for this particular one on the screen, an example of that would be the buttons on the back and the interfaces on the back. Those interfaces are all different electrical components, and all those different electrical components actually have different heights to them, and they're sitting on a board that is not at all facing in the direction that you would think it would be facing. And getting them to be perfectly aligned how the industrial designer wants them to look is quite a feat between electrical engineering and mechanical engineering for us to come together and define that, but then also ensure that it fits in that position, which, as you can see in the top left image, is right near where the battery slides in, and ensuring that we've got enough space there for all of those electrical components to come together, fit, and be in the interface behind the facade of what the customer is going to see. So these are kind of some of the nuances we deal with, and they get handed off to manufacturing, who manufactures them, and we work through the iterations and design changes that need to come into place once that manufactured product is released and out the door. So it's a very neat product, and it's fun to get to work with all of those different people. At Newell, I was working on that front, what I would call more of the front end, of starting with sketches and understanding the desires of marketing, and working with industrial designers and having customers come in and play with my prototypes and get their feedback on the functionality and the form and all of that. And it's a lot of fun and a great part of the mechanical engineering, but I would then hand it off to manufacturing, and I would see it again, but I wouldn't be there for the pains, the growing pains of actually executing. So I moved to the back end with my move here to San Diego. I happened to be married to a brilliant nuclear engineer. He completed his PhD at Georgia Tech, and we then relocated here to San Diego for his first job. And I completed this project on the screen while we were here working remotely. My time was quite extensive working on this project over those different time zones. I'm pretty sure I started at 4 a.m. every day and may not have ended until midnight just because of all the different teammates and places around the world that I was driving. But it was a neat project. And when I completed that, I then looked around here in San Diego and learned that we have a very medically heavy focused industry here and decided to join BD. And so that's where I am today. I'm here at Becton Dickinson. I am currently an R&D manager. I did not start as an R&D manager, though. I started as an individual contributor at BD in the medical delivery solutions business unit at BD. And so at BD, I'm responsible for our infusion delivery. So we have IV sets. When you're in the hospital, when drugs are being delivered to you, they're often given to you via those tubes that either go into a machine or directly from a bag into your arm or another vein location in your body. And I'm responsible for putting together those IV sets, deciding what the validation tests are required to be able to release that and ensure that they're safe and effective for use, and that we have all the documentation necessary to submit them to a regulatory body, whether here in the US, the FDA, or outside the US, to those regulatory bodies and provide evidence that they are going to be safe and effective for our patients. So that's the kind of work that I did as an individual contributor, is designing and developing those. I kind of call it like Legos, picking out a different group of Legos, putting those Legos together, and then ensuring that they're going to work functionally for the needs that that particular set has. We have hundreds of different designs of sets, hundreds of different opportunities for different uses. A use case could be in oncology for a cancer patient, which has a different use than a set that's used in by an anesthesiologist or an anesthetist during an operation. So there's all sorts of different sets and configurations, and each of them have different use cases and user needs. And putting those all together and then working with manufacturing to build them. We do things called IQ, OQ, PQ. So we ensure that they're going to be properly built and can be built over and over and over and over again effectively, because we make billions of these. And then making sure from a testing perspective that we're confident that they're not going to fall apart, that they are flowing at the speed that they need to be, that they're delivering the drugs as they're intended to, that there's no leaks, that there's no separations, that they're just not going to fall apart, and all sorts of other tests that we perform to ensure, again, that they're safe and effective. I transitioned about a year and a half ago into management, which I was really excited about. I really enjoy leading and coaching teams and connecting them with information and people. And it's been a great joy for me to get to do that. I stepped into a managerial role first, managing a group of lab technicians. So the people who are actually performing the tests, the engineers, we write how and what to test, and then technicians go in and they actually perform the tests, whether it's on an Instron for pull testing or an HBLT for burst and leak testing or other tests like that. That's the team that I manage now here in San Diego. And then most recently in the fall, I added some engineers to my group, and I'm managing people that look like me and act like me from a few years ago. And I'm driving the specific business in our IVA connectors, so our connector business, and ensuring that those are supported from a sustaining perspective. So we release products into the market and we have to sustain them, whether it's a material no longer exists in the field, we need to replace that material and ensure that that material is going to be equivalently safe and effective, or maybe it's a choice to have a different supplier provide a product to us, and we need to validate that that's okay, and all sorts of other sustaining activities to ensure that our business continuity is maintained. That is my job today. And in addition to that role, I am also the Women's Initiative Network lead from a STEM perspective at BD. And like Reed introduced me, I am the Society of Women Engineers president. And from a SWE perspective, just to introduce you to that journey, I was introduced to SWE at Georgia Tech My first week at Georgia Tech, they have something called the Tea with the Dean, where the Dean of Engineering introduces himself or herself to all of the incoming freshman women who are invited to this tea and get to learn about the Society of Women Engineers. So that was my first introduction. I had a strong connection to some of the other female associates there, and with mechanical engineering being only 10% women at the time, and maybe still today, it was a great way for me to have an expanded network, a sorority of sorts within Georgia Tech, and have that connectivity. SWE afforded me the opportunity to not only learn and get connected from a networking perspective, but learn about the companies that exist. So getting to learn about the different ways that mechanical engineers are out in the field, from Schlumberger out on an oil rig to Newell Brands and designing strollers. We had all sorts of different companies come in, and I got to hear every Tuesday, have dinner, and have a new company come and present and talk to me and the other SWE members at Georgia Tech, and learn about the opportunities that we can be afforded in the future. I became, after graduation, I became the vice president of outreach in Atlanta for the professional chapter, where I may have been avoiding outreach as a collegiate, but was really excited about outreach as a professional, and ran a lot of outreach activities for local students, and was proud of a summer program that I put together for high school rising juniors and seniors, where they visited 5 different companies, 1 company a day, in the summertime, to learn about what the different company does and what the different engineering disciplines that they typically hire and what the job day-to-day looks like for them. And then when moving here to San Diego, I got involved in outreach here with our SWEET program, which is an annual program that we used to have for students, and got involved then with professional development, got connected with BD's internal network, and am now the SWE president, and have been so for the last 2 fiscal years. And I'm really excited for the work I've been able to accomplish, especially during a pandemic, in this leadership capacity. So with that, we've got about 18 minutes, and I'm happy to stay longer if needed, but I'd love to open up the floor to any questions about my journey, specifically professionally, or with SWE, or any other personal questions you guys would like to ask. But thank you for your time tonight. What questions can I answer? And feel free to put them in the chat window.
Kelly.
So,
Yeah.
okay, someone else is asking a question.
Go ahead.
Oh, I'm one of the parents. It's just amazing that the range of things you managed to do. So it certainly takes a lot of drive on your own end, but also a lot of opportunities that will come your way. So if you could share with us how, because some of the projects you did were so different one from the other. How did all these opportunities come to you, and how do you take advantage of them? And
It's a great question.
student.
Yes. So I will tell you a story about my very first internship. So spring break was about to come around. I didn't have an internship lined up for my freshman summer. My parents made me come home for spring break. I was not too happy about it. But I literally had a cover letter that I had written and my resume printed and folded it up, and I put it in an envelope and sent it to the top 20 engineering firms in the DC area. There's this thing called a book of lists, which can be found at the library. And I didn't know anything better and just used that and sent it out to the top 20 firms. And when I got home over spring break, I reached out and called all those 20 firms to see if they had received my letter, which also included a picture of me, of course, and saw to see if any of them would be interested in having me as an intern for the summer. And one of them bit, which was really exciting. And I did an interview in person during spring break that week and was able to solidify that opportunity. So While that may sound very old school, it's an approach that did work for me. And I think it's about exactly what you spoke about. It's about having that interest and that drive. But I think it's also about having support in place, right? So having people in your network that can encourage you to pursue things that maybe you weren't wanting to go and try. But it's about being creative in some of those things as well. Identifying what you're interested in to do is important, and then leveraging the people to make that happen. Another example I'll just share very quickly is I had a mentee and she really wanted to work at Disney. I didn't know anybody at Disney, but I said, let's pop on LinkedIn. Let me see who we know. Let's look at Georgia Tech's alumni network. Let me see who we can find. And we were able to find a few people that she was able to connect with. And through that connectivity, we were able to get her an internship at Disney. So I think it's about being creative, pursuing things, trying many different angles. Just like you do a Sudoku, you don't solve it one way and that's the only way. You got to solve it from all the different angles and approach it from that way. Does that help answer your question? Is there any secondary question there maybe?
No, that's a great answer. I have actually a follow-up question from your answer.
Yeah.
That is
Sure.
about mentorship and relationship with your mentor and mentee. So obviously in college, you look in high school even, and we have in this group a lot of parent mentors who are just, not only role models, but just provide a lot of help. So in college, for example, how do you approach someone that you admire and say, I want to work with you, I want to learn from you, and to establish that kind of mentor-mentee relationship? And how did you do that specifically?
So there are formal mentoring programs that are available. SWE, for example, at Georgia Tech had a formal mentoring program that connected students from undergrad, like lower freshmen, sophomores with juniors and seniors. So they had that matching program. Also the Women in Engineering group at Georgia Tech also had a mentoring program. So there's mentoring opportunities from that perspective. And I think the Women in Engineering ones connected us with professionals. So there's also sort of formal ones that you just sign up for and they match you and you're kind of good to go. From an informal mentoring situation, which is what you were a little bit alluding to more so, is one where I tend to like to have those form organically. So somebody is a mentor, is somebody that you're connected to and observing regularly. So it's okay to just take them to coffee and ask them a few questions conversationally, to observe them, to participate in an event together. I love doing that. To say, hey, I'm going to this event. Would you like to join me? So those are some of those ways. And then while you're together at those events, that's the chance for you to be asking some of those questions or asking them, hey, are you doing any events related to this activity? If so, I'd love to join you. Those are the kinds of things that I'd recommend when it comes to mentoring. So I would say I had mostly formal mentors through Georgia Tech, and then informally, I call them like champions and advocates and mentors all together. And then at a professional level, this is something I do encourage when anybody's entering their first time job. It's a softball to HR. When you're negotiating, I negotiate not just on my salary, but I also negotiate to have an official mentor. And sometimes they have to scramble to try and find a female VP that's in engineering. There may only be one, but I have it in my request in the counter offer to say that I would like an official mentor defined before my first day. That will be my mentor at that new company.
That's a great idea. Great. Thank you.
Yeah, my pleasure. Thank you for coming tonight.
I have a question. What is the Women's Initiative group at Becton Dickinson that you're a part of, or what is that?
Yeah, so many companies have associate resource groups or employee resource groups. Those are employee-led, volunteer-led groups that are intended to provide networks and senses of belonging to associates. So many companies are starting to have more of these today. Newell had them as well when I was part of that large organization. It tends to be larger organizations that have them. And they put together programs. Maybe it's a mentorship program, maybe it's a series on allyship, whatever it may be. At BD, we have 9 ARGs. So the Women's Initiative Network is one that's targeted towards advancing and supporting the advancement of women, and then in their careers and their aspirations. We also have other ARGs such as the African Americans, vets, Asia Pacific, yeah, so nine different ARGs. We also have one called Limitless, which I believe is for parents, and we have one called Next, which is really people that are focused on the innovation, what's next for BD. So yeah, that's what the ARGs are. Thank you for your question.
Kelly,
Yes.
can you talk a little bit about your scholarship and endowment at Georgia Tech? Because I think it's pretty cool.
Sure. My husband and I, we recently decided to contribute to Georgia Tech through an endowment scholarship. For those of you that aren't familiar with that term, it's basically a scholarship that will be in existence in perpetuity for forever. And this is very important to us because we wanted to know where our money was going and that it was going towards a purposeful cause. And so our personal purpose is to make good and to support good global citizens. And so we created 2 endowment scholarships, one for my professor in the LBAT program, which is the Language, Business, and Technology program. I have a German minor, and she led the summer program that I participated in my sophomore summer, where I visited all those manufacturing plants in Germany. And then my second one is for a student at Georgia Tech, male or female, who is the top student in mechanical or nuclear engineering that is a SWE member. And that particular endowment is named after a very important person in my life who's actually now located here in San Diego, but she was the vice provost of Georgia Tech and an advisor to SWE Georgia Tech at the time when I was a student, and treasurer for Georgia Tech. And so again, that is an exciting one that we're really pleased to have been able to fund, especially at such a young age, to be able to do that. We're very pleased with the students that we're excited to be able to give that scholarship to. And as a recipient of a scholarship at Georgia Tech through SWE and through the Women in Engineering, I actually tended to use those scholarships to give back. And so we feel as though by us giving back to Georgia Tech, with these kinds of students in mind, we feel as though it will continue to contribute to society in that manner, because these are, again, intended towards people that I think will be truly good global citizens. Thank you for the question, Tracy.
Absolutely. I think it's just amazing what you're doing. So inspiring. Thank you, Kelly.
Yeah. Yeah, SWE has just been a very important piece in my life. The first company that I worked for, full-time, Big Bang, we were, I think, 8 people, and I was the only female engineer. And we talk about imposter syndrome, right? And maybe it's not a term that we're not wanting to use too much anymore, but it is a real thing, of the fact that sometimes you feel as though you're overwhelmed and you don't know that this is the right career path or the right choice for you in the long run. And females in engineering, they call it like a hockey stick. So we graduate a ton of women in engineering, which is awesome. But unfortunately, the number of women that are retained after 5 years in the field is very few. And so it's a hockey stick curve where you start off with a ton, and then after 5 years, you don't have very many left. But the ones who survive the 5 years are the ones who will continue to be there, which is really exciting. So I've survived the first 5 years. And the survival is only in part because of my engagement with SWE. I call it my pep rally every year when I get to go to the annual conference, which I've been doing since college, basically. And it's a great organization for me to be inspired by other engineers, to have a network of people that are there to support me in all the different career stages I'm in, and really be an advocate for this discipline as a career option and choice for women around the world. So I'm really pleased with the organization and happy to sponsor and financially support this organization.
And what, in your opinion, is the best way to check for like events or opportunities offered by SWE here locally in San Diego?
Excellent question. So we, as a SWE organization, have many different events. If you're a professional, getting connected with SWE San Diego through our social media accounts is a great way to find out about those kinds of events. If you're a student, we have many SWENext clubs here in the area, and they often are cross-pollinating their events and activities, which is really neat to see. Again, leveraging the social media. There is a SWENext San Diego social media account that that the SWENext clubs leverage to share their information, so then they can share it back down through that Instagram account. So that's another great channel. And then for collegiates, they should be getting connected and engaged at the collegiate level and understanding what channels that those communicate through. But yeah, we've got a number of collegiate schools, I think 5 or 6 here in the area now that have SWE integrated in, which is really exciting to see.
Do we have any last questions? Also, feel free to type any in the chat if anyone's microphone isn't working, and we can read those out.
Thanks, Reed.
Hi, I'm Yohei,
Hello.
one of the parents. I was just wondering, just what can be done to help retain women as engineers after that 5 years? I mean, is there anything that any of us could be doing?
Yeah, it's an excellent question. So we talk a lot about allies, right? And having an ally in the room. So it's about having the mindset around, do I have the right person at the table? Right? We want to make sure that women feel as though they belong there. So encouraging them to come sit at the actual table too, like not in the corner, making sure that women are not assigned the housework of work, right? So we're not always planning the parties or whatever it is, ensuring that their voices are heard and amplified, as well as ensuring that they have the growth opportunities that they can see. So even if there's a female, there's no female leaders in your direct organization, helping open up their eyes to other women who do exist in the organization, but they may not be aware of, that have moved up, right? Because a lot of times if they feel like they don't see anyone that looks like them in their group, and then they don't see anybody that looks like them in their chain of command, it's really disheartening. But when you can connect them to people in the organization or outside the organization that can help them in their challenges and journeys, I think that's a great way to be an ally and supporter. Thank you for the question, Yohei. I hope that gave you a few tips.
Yeah.
Yeah. Any other last minute questions as we wrap up? It's been an absolute pleasure being able to share my story with you all. Quite a journey, as you can see. I think in a previous session, somebody pointed out, there's not one path. There are many different paths you can take. Ultimately, I think the focus should be on making sure you know what your story is, what the narrative that is that you want to be saying in your story, being able to connect those dots for somebody if they do ask you why you did something, that you have a purposeful reason for why you chose to do that, and making sure that you know what that North guiding star is. And it's okay if it changes in your journey, but at the same time, making sure that you're true to yourself and true to your values, and that we have all the support and team members behind us. We don't leave people behind us on the ground, but we take them with us too. So keep that in mind too. Open up doors and keep them open for the person behind you. Bring them along, and we'll continue to advance this field and this opportunity for others. So thank you so much again for your time.
Thank
I
you
think
so much.
wanting to take a picture. So maybe if you do have your cameras and can take a photo real quick, we'd love to do that. Thank you. I see them coming on. Yeah, he's got a smile going. He's ready to go. Reed, will you be able to take a picture?
Yeah, I'm taking a few right now.
Okay, wonderful.
Yeah, I would just want to thank Kelly also and Dr. Nguyen for coming. Appreciate the support.
It's my pleasure. Did you get a couple, Reed? You
Yeah,
good?
I got a few.
Okay.
All right.
So I keep smiling forever. And I just want to
That's
say,
great.
yeah, Tracy,
so
thank
friendly, yeah.
you. Want to thank Dr. Nguyen for being our counselor. And you know, this is this club's first step to becoming an ally and learning what we can do to support. So we really appreciate everyone's support tonight and everyone coming out.
Definitely. Have a wonderful evening and happy to support you in future events. But thank you again for the invitation and for this kickoff. Good night.
Thank you.
Thank you.
Good night.
Hi,
May I
thank you,
ask you a
Kelly.
question?
Thank you, Tracy. Thank you,
Yes.
Dan.
I'm sorry. I was trying to find
that's
like a
okay.
good time, but then I just kind of failed.
No, you're
But
fine.
anyway, what was your path like to becoming like an engineer in medical?
Yeah. So I don't have a background in biomedical at all. My only experience pre-BD was with the sternal retractor and the open heart surgery. I got to work in a cadaver lab and a pig lab, you know, trying my device on dead people and on pigs, kind of neat, kind of smelly. And so that was my experience before BD in medical. And then when I moved here to San Diego, like I said, I just saw that there was a lot of medical device companies here. And I actually was looking at consumer products because that's my background, connected with a Georgia Tech alumni who worked at a company, or I thought had worked at a company I was interested in. He said, you don't want to work here, but I have a friend who has an open position and you might want to work at BD. And I interviewed for that job. That job would have been about half the salary I actually started at BD. So know your worth. I rejected that position, but we had such a great interview and they had other position opportunities available. And he connected me with a different person at BD who ended up being my hiring manager, and it was the proper fit for me. So kind of an indirect path, not one of medical that I was pursuing directly, but at the same time, my skills were very, very transferable. So having the experience that I had with many projects, with leading teams, with driving robustness, with having technical excellence, and some hard skills like SolidWorks and design for Six Sigma and things of that nature enabled me to pivot in the industry. So you don't always need to be so industry specific, but if you have some transferable skills within your core of mechanical engineering or whatever your degree is, those skills can enable you to switch quite easily. Does that answer your question okay?
Yeah, thank you very much.
Yeah, my pleasure. Okay. I'm happy to answer any other last minute questions if you've got them.
I think it's
Thank you. Well, thank you
all
so
right.
much.
Thank you.
Thank you
Good
so
night.
much. Bye.
Thank you.
Thank
now.
you. Thank you, everyone.